Alright, we have another problem in fluid mechanics, particularly about fluid dynamics or fundamentals of fluid flow. So, basahin na natin yung problem. Okay. Water enters a mixing device through pipe A at 150 liters per second, while oil with specific gravity of 0.8 is forced in at 30 liters per second through pipe B, which is this. If the fluids are incompressible and form a homogeneous mixture of oil globules in water, find the average velocity and density of the mixture leaving through the 30 centimeter diameter pipe C. So, meron daw tayong mixing device kung saan sa pipe A may pumasok na water at sa pipe B may pumasok na oil. So, hinahanap yung velocity sa pipe C. So, the velocity at pipe C and the density of the mixture, sabihin na rin natin the density at C. So, that is our missing values or variables for this problem. So, how will we solve this problem? Sabi sa problem, it is the fluids are incompressible. So, the conservation of mass applies to this problem. So, what is that? What is the conservation of mass? The conservation of mass simply states what? The mass flow rate going in the system is equal to the mass flow rate going out. Ibig sabihin, there's no change in our mass flow rate. Kung anong pumasok, siya ring lalabas. Ayun. Nasusulat yun. So summing up the mass flow rate going in our system here is, let's just say the mass flow rate at A plus the mass flow rate at pipe B is equal to the mass flow rate going out, which is at pipe C. Okay. Now from here, we know that the formula again, mass flow rate is equal to what? Density times the cross-sectional area times the velocity. So, substitute lang natin, or simply rho times Q. So, it's better if we use Q para mas mabilis. So, for A, we have here the density of A times the volume flow rate at A plus the density at B times the volume flow rate at B is equal to the density at C times the volume flow rate at C. Alright. Now, we have at A, ang pumapasok ay water. And we know that the density of water is 1,000 kilogram per cubic meters. Let's write the units para makita natin yung unit analysis later on. And we are given with QA 0. Diba 150 liters per second. Tapos divide mo lang na 1,000, you'll get 0.15, that is in cubic meters per second. And for pipe B naman, we're given SG ng oil. So, simply write it down, tapos multiply mo sa density ng water to get the density of oil. And multiply that to the given naman, yung volume flow rate sa pipe B. Diba 30 liters per second divided by 1,000, you'll get 0.03 cubic meters per second. And that is all equal to the density at pipe C, which we are looking for, and the volume flow rate at C. So, pressing all these values into our calculator, we will arrive with the value of, for PC and QC, PC-QC, pinindot mo yan, lalabas ay 174. Anong unit? Cancel lang yung cubic meters sa pareho. So, we will end up with the unit of kilogram per second. Ayun. So, but we know that Q is equal to AV. PC is equal to, di ba ang Q ay A times velocity. So, Ang area natin is bilog naman kasi it's a pipe. So we have pi over 4. Ano yung diameter? Given yung diameter sa C, which is 30 centimeters. Convert mo lang sa meters, that will be 0.3 meters. 0.3 meters, tapos dapat naka-squared, times the velocity. This is 174 kilogram per second. At pag dinivide natin yan ng itong area na to, PC times the velocity is equal to 174 divided by pi over 4, 0.3 squared. You'll get 2461.60. Our resulting unit will be kilogram per square meter second. So, hayaan lang muna natin yan. We are missing two variables, yung dalawang hinahanap natin. So, we need another equation. So, saan natin siya kukunin? We will get our next equation sa continuity equation naman. So, the continuity equation naman, yung Qn is equal to Q out. So, gagamitin lang natin yun to solve for the missing. So, we'll have another equation na magagamit natin para mahanap yung mga nawawalang variables. So, we know that Qn is equal to Q out. The volume flow rate going in and the volume flow rate going out. And from our diagram, ang pumapasok na volume flow rate ay sa A at sa B. Tapos lumalabas si C. Now from here, this is QA plus QB is equal to the volume flow rate at Q sub C. We have the value of QA and QB, which is 0.15 plus 0.03. So this is 0.15 plus 0.03 at pareho silang naka cubic meters per second equal to QC. From here, volume flow rate at C is equal to simply 0.18 cubic meters per second. Now na alam na natin yan, we could solve for the velocity. Kasi, we know, di ba meron na tayo nito? Yan. Alam natin that Q is equal to area times velocity. So, for C, we need the area of C and the velocity at C. Meron tayong area kasi may given tayong diameter, which is ito, 30 centimeters or simply 0.3 meters. So, the velocity at C is simply equal to itong nakuha natin, 0.18 cubic meters per second divided by the area, which is a circle. Cross-sectional area is a circle kasi pipe, diba? Pi over 4 times the diameter, 0.3, tama ba? 0.3 meters squared. So, cancel yung, diba, cubic meters, may matitirang isang meter. So, our resulting unit will be meter per second. From here, our velocity is equal to approximately 2.55. Oh, bakit ng 5? 2.55 mga kasama. 2.55 yung velocity natin sa C. So, that is our answer for the velocity. Ayan, may velocity ni tayo. At gamit yung itong nakuha nating relationship kanina, meron na tayong V, yung velocity at C. We will simply divide. Diba? So, PC is equal to, 2461.60. 0.60, ang unit ay kilogram per square meter second, divided by nakuha nating velocity, which is 2.55. 55, that is meters per second. As you can see, the units ay nagtutugma. Cancel out yung seconds. Kakancel out yung seconds. Shing, shing. Shing, shing. Tapos, itong meters na to, mamumultiply dun sa isang meter, resulting 2 cubic meters. So, tama yung units. Kilogram per cubic meter. So, our resulting density of the mixture or in pipe C is simply equal to, pressing this into your calculator, you'll arrive with 965.34 kilogram per cubic meters. Ayan. That is our density, the density of the mixture ng ating water and oil globules. Social. So that is all for this problem. Medyo we're stepping up a bit. Okay. Mahalaga dito yung alam mo yung formulang to and yung principle ng conservation of mass as well as the continuity equation. Volume flow rate in is equal to volume flow rate out for incompressible flows. Okay, that is our final answer. Social.